Okay, let's get started. So in this task, we are going to see how to implement CPU in HDL file. Okay, first of all, there are three inputs, that is input by the user of 16-bit, data instruction 16-bit, and a reset. Next, there is output M, which gives output like memory data, memory data value of output. Write M if anything is overwritten. Address of M, M register, and a program counter. Okay, this was like a header to CPU. We can also see here that there are three inputs and four outputs. Okay, now that it's done, coming to the main part. So here in first two lines it says like if the instruction, it checks if an instruction is an A instruction or C instruction. If it is an A instruction, it will take the value of instruction in and output it as AINS, that is A instruction. It is used by the NOT gate and all. Secondly, it will take as A instruction as well and output as C instruction, like because opposite of A instruction is C instruction. Okay, in next line it will check if it's a C instruction, and here we can see how it is done using the AND gate. Like it takes C instruction and then in other values it will take instruction of five bits, and it will value it as output value is ALU to A. Okay, in next line it says selects which value should go to an A register. Here the choices we have are instruction and ALU out, and it is determined by the ALU to A, which we get in output to the C instruction, and it gives us output A R E G I N, A register in. Okay, next step, it says if A register is loaded to A, like in our we use OR gate and A register. It takes the A instruction as its one input and ALU to A as B, and output it as load of A. Now here comes the A register. It takes the input as the output which we get in mux gate of selects it which value should go into the A register, and load it as load A, which we get previous slide in previous code, and output it as A out. Okay, now it selects if the value is going to A register or M register. Here again it is mux is used because there is selection and is selected by the instruction of for 12 bits, and output it as AM out. Okay, now it is checked if the output we get is loaded in the D register. And how it is done, it in AND gate we take C instruction as its input value and instruction of 4 bits as B as like second input, and output it as load of D because it's finally decides like if we are getting in which value exactly, what value is getting in D register. Then we select the D register and input it as ALU out and load of load D, which we got in previous code, and output it as D out. Okay, now the ALU is selected and all the logical computations, that arithmetic computation, logical computations are done here. You can see that. Okay, then if it is checked if the CPU can write on the data memory. Here it is like if A is false, like we have given it as a false value and B as an A out, and out of 15-bit, like 15-bit address is given to address M. Same thing happens to ALU out with output out M. And AND gate is used, which takes the value in C instruction and an instruction of 3 bits, and output is write M, which writes them into the memory data. Now it checks the value. If the value is true, the jumps will happen according to that. Like if the value is 0, the jump will happen. If the value is negative, the jump will happen, and so on. And when it is all done, it loads the PC counter. Now we have like C instruction, and our and the output we got in the previous part of code was jump to A. Now those two are connected through AND gate, and output is collected as PC load, which will determine the PC is loaded or it will continue in loop. And then we have PC like program counter, which we all know. It takes input as A out, increment as P increment, load as PC load, reset as reset. We all know like it is predefined, and output of 15 bit rate 15 bits is program counter. And here we are done with our code. Thank you so much.